Okay, so one of the, sort of critical ionotropic receptors, the postsynaptic receptors, right, for glutamate, is something called the NMDA receptor. And I want you to really get a handle on this, because the NMDA receptor is going to be a site of drug action for, a commonly, used and occasionally abused drug known as alcohol. So if we look at a typical postsynaptic membrane and a glutamate synapse, so there's our glutamate, right, that chemical up there. Here's our phospholipid bilayer, right, of the postsynaptic cell, the next cell, right, that's going to be responding to glutamate released presynaptically. We're going to find, some of these glutamate receptors that are present in this membrane, right? And there are some receptors, right, that will, when glutamate binds, shift their position, right, and they will open a channel that will let sodium go through. And if sodium is permitted to go through this postsynaptic membrane, sodium's going to come in, right? Remember, the concentration gradient force is going to push it in, and the electrical force is going to push it in, right? And when a positive ion comes in to minus 65 in here, it's going to depolarize this cell and take it towards threshold for an action potential. So this is at low levels of activity, right? Basically, when there's a little bit of glutamate out here, primarily this set of receptors over here are responding. The NMDA receptor is not responding at low levels of stimulation. And the reason is because this particular protein is shaped in such a fashion that it actually has in its channel, the channel that needs to open to let ions go through, it has an ion sitting there. This is a magnesium ion that, at low levels of activity at a glutamate synapse is just sort of stuck in the center of this channel and prevents the passage of sodium and calcium, from the outside of the cell into the cell at low levels of stimulation, right? So at low levels of depolarization, not much neuronal activity occurring, not much significant going on, just a certain level of stimulation. NMDA receptor channel is blocked by magnesium, and the stimulation of glutamate and the depolarization of the next cell, the excitation that glutamate produces in the next cell, is mediated by these receptors over here.